The autumn of 1943, in the cold grey expanse of the North Atlantic, the tide of war had at long last turned. After 4 brutal years, the hunters had become the hunted. Admiral Karl Donitz's U-boat wolfpacks, once the terror of the shipping lanes, were now being systematically dismantled. Allied codebreakers at Bletchley Park listened to their every command. Long-range Liberator bombers, bristling with new centimetric radar, stalked them from the skies. And on the surface, the convoy escorts, tenacious destroyers, frigates and corvettes had become ruthlessly efficient submarine killers. For the first time, it seemed the lifeline of men and material from America to Britain was secure. The U-boat menace was broken. Then the reports began to filter in, whispers at first, then panicked radio transmissions. Something was wrong. On September 20th, convoy ON-202 was fighting its way westward. The escort group was strong, veteran. Suddenly the British frigate HMS Lagan was rocked by a colossal explosion. Her stern was obliterated. She did not sink, but she was out of the war. Hours later, the Canadian destroyer HMS St. Croix, a hardened U-boat killer, was hit, and then hit again. She vanished beneath the waves in minutes, as another escort, the corvette HMS Polyanthus, raced to rescue survivors. It too was struck and disappeared. 3 escorts, the very guardians of the convoy, were eliminated in a single action. And the merchant ships, the supposed targets, were untouched. This was not the work of a conventional torpedo. This was something new, something predatory. The torpedoes weren't being aimed, they were hunting. They could hear. The Allies now faced a horrifying and seemingly impossible problem. How do you fight a weapon that uses your own ship's heartbeat as a homing beacon? How do you evade an enemy that is drawn to the very sound of your escape? The crisis facing the German Kriegsmarine in mid-1943 cannot be overstated. It was a catastrophe. The Black May of that year had seen the U-boat force suffer unsustainable losses. 41 boats lost for only 34 Allied ships sunk. Admiral Donitz, who had once boasted that the U-boat alone could win the war, now saw his weapon being blunted and broken. The primary culprit was technology. Allied high-frequency direction finding, or HUF-DUF, could pinpoint a U-boat's location the moment it transmitted a radio message. Shipborne and airborne radar, particularly the new 10-centimeter models, could detect a surfaced submarine from miles away, day or night, in any weather. The U-boats were being forced to spend more and more time submerged, blind and slow, while the skies and seas above them teemed with enemies. Donitz needed a game-changer, not just an improvement, but a revolutionary leap in technology that could once again tip the scales. His engineers presented him with the answer. A weapon that would turn the Allies' greatest strength, their fast, aggressive escort ships, into their greatest vulnerability. It was the G7ES acoustic torpedo, designated Zunkönig, or Wren. The Allies would come to know it by a simpler, more sinister name. The Gnat, for German Naval acoustic torpedo. The Gnat was a marvel of destructive engineering. It was an electrically propelled torpedo, meaning it left no telltale wake of bubbles for sharp-eyed lookouts to spot. But its true genius lay in its nosecon. Instead of a simple impact or magnetic detonator, the T5, as the Zunkönig was also known, was equipped with a sophisticated acoustic homing system. Within its warhead were 2 sensitive hydrophones, functioning like a pair of ears, tuned to a very specific and deadly frequency range, 20 to 30 kHz. This frequency was not chosen at random. German engineers had spent years studying the acoustic signatures of different ships. They discovered that the sound of a ship's propellers churning through the water, a phenomenon known as cavitation, produces a distinct noise profile. Large, slow-moving merchant ships with their massive, slowly rotating screws produced a low-frequency rumble, but the fast warships of a convoy escort, the destroyers and corvettes, used smaller, rapidly spinning propellers. To achieve their high speeds, these propellers spun so fast that they created tiny vacuum bubbles in the water, which would then collapse with a sharp, high-frequency hiss. This sound fell squarely in the 20 to 30 kHz range. The Gnat was, in effect, deaf to the slow merchantman of a convoy. It was designed to hear only one thing, the sound of the hunters. The tactical doctrine was terrifyingly simple. A U-boat commander no longer needed a complex firing solution. He didn't need to calculate the target's speed, range, and angle on the bow. He simply had to get within a few thousand yards of a convoy, point his boat in the general direction of an escort's engine noises, and fire. Once in the water, the Gnat would run straight for about 400 meters to clear the noise of its parent U-boat. Then its acoustic sensors would activate. It would begin to listen. Upon detecting the high-frequency signature of an Escort's propellers, its guidance system would take over, steering the torpedo directly towards the loudest source of that sound. For an Escort commander, every instinct, every trained tactical response was now a death sentence. A U-boat is detected, increase speed to close for an attack. The propellers spin faster, the cavitation noise intensifies, and the Gnat hears you more clearly. An incoming torpedo is spotted, execute a hard turn at full emergency power. The thrashing screws scream an acoustic beacon for the Gnat to follow. The very act of maneuvering to save your ship made you a more perfect target. The weapon was diabolical. It turned a warship's agility and power against itself. The first operational use of the Gnat in September of 1943 was a profound shock to the Allied naval commands. The loss of the destroyers and corvettes protecting convoys on 202 and ONS 18 was a brutal demonstration of the weapon's effectiveness. In these two battles alone, 6 escort vessels and a half-dozen merchant ships were sunk. The Allies had been poised to declare victory in the Battle of the Atlantic. Now, suddenly, their most vital assets, the sheepdogs of the sea, were being slaughtered. The U-boats were no longer targeting the flock. They were eliminating the shepherds one by one. The Admiralty in London and the Navy Department in Washington, D.C. realized they were facing a threat that could undo years of progress and sacrifice. An answer had to be found, and it had to be found immediately. The initial reaction in the Allied command structure was one of controlled panic. They had possessed intelligence, gleaned from Enigma decrypts and prisoner interrogations, about a German acoustic torpedo for some time. But intelligence reports are one thing. The visceral shock of watching your most capable warships disappear in pillars of fire and smoke is another. The weapon was no longer a theoretical threat. It was a clear and present danger, and it was working with horrifying efficiency. The first tactical directives issued to escort commanders were born of desperation. The most obvious, yet most flawed, was the order to go slow. Since the Gnat homed in on the noise of fast-turning propellers, the logic was to simply not make that noise. Escorts were ordered to reduce speed to below 9 knots, the theoretical threshold at which cavitation became significant. This was a tactical nightmare. An escort moving at the same speed as a merchant convoy was no longer an escort. It was just another target. It couldn't dash out to investigate a radar contact. It couldn't run down a suspected U-boat position. It couldn't circle back to rescue survivors without becoming a sitting duck. The go-slow order effectively neutered the entire anti-submarine warfare doctrine the Allies had so painstakingly built. Another early idea was the silent approach. An escort could hunt at low speed, then shut down its main engines entirely for the final attack run, coasting in on stored momentum. This was unworkable. A 1,000-ton destroyer does not simply glide silently through the water, and the moment it needed to maneuver or deploy depth charges, the engines would have to restart, broadcasting its position to any Gnat in the vicinity. The problem was handed over to the finest scientific minds in Britain and the United States. In the UK, the task fell to the Admiralty's Directorate of Miscellaneous Weapons Development, a deliberately understated name for a department of certified geniuses and eccentrics, led by the brilliant Canadian scientist Charles Goodeve. In the US, a parallel effort was underway at the Naval Research Laboratory, and within Division 6 of the National Defense Research Committee, or NDRC. These scientists quickly came to a fundamental conclusion. The noise of a warship could not be eliminated. The laws of physics were immutable. Steam turbine engine, its reduction gears and its propellers would always make noise, and the faster it went, the more noise it would make. Hiding was impossible. The solution, therefore, could not be one of silence. It had to be one of deception. If you can't make yourself quiet, you must create something else that is significantly louder. You needed to give the torpedo a more attractive, more delicious acoustic target to chase. A target that was nowhere near the ship itself. The concept of a towed acoustic decoy was born. The idea was simple in principle. Drag a noisemaker behind the ship on a long cable. When a Gnat was fired, it would hear both the ship and the decoy. If the decoy was sufficiently loud and produced the right kind of sound, the torpedo's simple guidance logic would lock onto the strongest signal, chasing the decoy and leaving the ship unharmed. But this elegant concept was fraught with technical challenges. What precisely should this noisemaker be? How do you generate the specific high-frequency signature of propeller cavitation? And how do you make it louder than an actual destroyer at full power? Early ideas were almost comical in their simplicity. One of the first proposals was to literally drag a large metal bucket filled with loose chains and scrap iron. The theory was that the tumbling metal would create a racket. It did, but it was the wrong kind of racket, unreliable, inconsistent, and not at the correct frequencies. Other more complex ideas involved water-powered turbines or spinning paddle wheels, devices designed to mechanically replicate the churning of propellers. These proved too complex, too fragile, and too difficult to manufacture and maintain on the scale required. The Allies needed thousands of these decoys, and they needed them months ago. The solution had to be simple, robust, cheap to produce, and operable by exhausted sailors in a North Atlantic gale. The search for the perfect noisemaker was on, and the fate of the Allied supply lines hung in the balance. The breakthrough came not from a single eureka moment, but from a process of iterative engineering and collaboration between British and American teams. The British effort, codenamed Foxer, and the American project, designated TAD for towed acoustic decoy, eventually converged on a design of brutalist simplicity and surprising effectiveness. The device that would ultimately blind Germany's hearing torpedo was not a product of sophisticated electronics, but of carefully engineered plumbing and basic physics. The solution was a pair of hollow metal bars, or pipes typically made of steel. Each bar was about 5 feet long and a few inches in diameter. They were connected by a yoke and a bridle, forming a V-shape that helped with towing stability. The true genius, however, was what was inside them. The bars were not empty. They contained loose metal strikers, essentially small, heavy hammers or solid cylinders of steel that were free to rattle around inside the hollow pipes. The device was towed behind the ship on a cable, typically 600 feet or about 200 meters long. As the ship moved through the water at a speed of 10 to 15 knots, water flowed over and around the two bars. This flow caused the bars to oscillate and vibrate, much like a flag flapping in the wind. This vibration in turn threw the metal strikers inside against the inner walls of the hollow bars. The result was an astonishingly loud, cacophonous racket. It was a continuous, broadband clatter of high-frequency noise. It was the acoustic equivalent of a welding arc, a symphony of tortured metal. This noise was perfect for two reasons. First, it was incredibly loud, far louder than the sound of the ship's own propellers. The Gnat's primitive guidance system was designed to home on the strongest signal, and the Foxer screamed for attention. Second, the noise was broadband. It wasn't a single, pure tone. It was a chaotic mess of sound across a wide spectrum of high frequencies. This was critical. It completely saturated the 20 to 30 kHz band that the Gnat's hydrophones were listening for. The torpedo couldn't distinguish the specific signature of propeller cavitation from the overwhelming wall of sound generated by the Foxer. It was like trying to hear a whisper in the middle of a rock concert. The decoy didn't just mimic the target's sound. It blinded the torpedo's senses with sheer brute force noise. The official designation for the British system was the Type 289, though it was universally known as Foxer. The American version, the FXR, was nearly identical and was often used interchangeably. By late 1943, a massive production effort was underway. Factories in the UK and US began churning out these simple-looking but life-saving devices. On the stern of every Atlantic escort, from the sleekest new destroyer to the humblest corvette, welders hastily installed a new piece of equipment. A small winch, loaded with 600 feet of towing cable, with the 2-bar Foxer Noisemaker clamped in a ready-use rack nearby. However, the Foxer was not a magic bullet. It came with severe and dangerous drawbacks. Its most significant disadvantage was that it was indiscriminate in its noise. The sound was so overwhelming that it completely blinded the towing ship's own ASDIC, or sonar. An escort streaming a Foxer was deaf. It could no longer hunt for submerged U-boats. It was a purely defensive measure, an acoustic shield, not a sword. This created an immediate and agonizing tactical dilemma for a ship's captain. When a U-boat was suspected nearby, do you stream the Foxer to protect yourself from a Gnat, thereby giving up your ability to find and kill the submarine? Or do you keep your sonar active to hunt the U-boat, leaving yourself murderously exposed to its new weapon? Furthermore, the physical act of towing the device was risky. The 600-foot-long cable was a hazard. In a high-speed, evasive turn, it was possible for the cable to become fouled in the ship's own propellers. Such an event would be catastrophic, potentially disabling the ship and leaving it dead in the water, a perfect, silent target. The cable could also snap under the strain, or the decoy itself could be damaged by the very torpedo it was meant to attract. The Foxer was a lifeline, but it was a fragile one. Demanding skill, discipline, and no small amount of luck from the crews who operated it, it was a desperate solution to a desperate problem, and its true test would come in the icy, unforgiving waters digging the Atlantic convoy routes. The race to equip the fleet was run at a frantic pace. By the opening months of 1944, nearly every Allied escort vessel operating in the North Atlantic had a Fokker winch bolted to its fantail. Training was rudimentary, often consisting of a few diagrams and a hastily published tactical manual. For many captains and crews, their first time deploying the device would be in the heat of combat, with the high-pitched whine of a Gnat's electric motor already audible on their hydrophones. Let us imagine a scene representative of countless encounters from that period. It is 2 a.m, somewhere in the Black Pit, the mid-Atlantic gap beyond the range of land-based air cover. A British Black Swan-class sloop, HMS Starling, is on the port screen of Convoy SC-150. The weather is foul, with a heaving sea and intermittent rain squalls. The ship is a world of shadows and shivering steel, the only light coming from the dim glow of the radar display and binnacle. Suddenly the ASDIC operator, hunched over his equipment in a cramped compartment below the bridge, stiffens. Through his headphones he hears the distinctive ping, echo of his sonar beam reflecting off a submerged object. ASDIC contact bearing green 45, range 2,000 yards. The bridge springs to life. The captain orders, right full rudder, all engines ahead full, stand by depth charge attack. Starling heels over, its screws biting into the black water, the deck vibrating as the turbines spool up to maximum power. The ship is now a hunter, accelerating to run down the U-boat. But in doing so it has just rung the dinner bell. Miles away, the U-boat commander, having already been detected, does not wait. He fires a spread, not at the convoy but at the charging escort. One of his torpedoes is a Gnat. Aboard Starling, a new sound cuts through the noise, a high-frequency, rhythmic pulsing, rapidly increasing in pitch. The hydrophone operator's voice is tight with tension. Torpedo in the water, high-speed screws bearing green 90 closing fast. This is the moment of truth, the nexus of the captain's tactical nightmare. His ship is thundering towards the U-boat, but an invisible predator is now screaming towards his stern. Attack or defend, he makes his decision in a heartbeat. Stream the Fokker, hard to starboard. I want that noisemaker between us and the fish. On the quarterdeck, a team of sailors wrestle the Fokker from its rack and heave it over the stern. The winch operator releases the brake, and the steel cable spools out rapidly into the ship's churning wake. As Starling executes a gut-wrenching turn, the 600 feet of cable pays out. The moment the Fokker hits its towing depth, a deafening grinding rattle is felt through the very hull of the ship. On the ASDIC set, the operator flinches. His display is now a meaningless wash of white noise. They are deaf. The next 90 seconds are an eternity. The ship is running blind from a torpedo it can no longer track. Every man on board is rigid, waiting for the inevitable cataclysmic impact. The captain stands on the bridge wing, staring grimly into the darkness astern, where he knows his ship is dragging its rattling sacrificial lamb. Then it comes. Not the bone-jarring slam of a direct hit, but a deeper, more distant crump. A dull, heavy percussion felt through the soles of their boots. A geyser of white water erupts in the darkness, 500 feet off the starboard quarter. The Gnat, seduced by the Fokker's siren song of chaotic noise, has attacked the decoy, detonating harmlessly at the end of its tow cable. A collective, unspoken sigh of relief washes over the ship. The Germans were utterly baffled. Their U-boat commanders began filing reports of perfect attacks. They would hear the click, click, click of their torpedo's propeller, followed by the telltale sound of its homing system locking onto a target. They would count down the seconds, and then, right on schedule, a loud detonation, a confirmed kill. But then through their periscopes they would see the destroyer or corvette, wreathed in smoke and steam but still moving, still very much afloat. The torpedoes, they concluded, must be detonating prematurely. The acoustic homing system must be too sensitive. Back in Germany, engineers scrambled to recalibrate the Gnat's guidance, never suspecting the simple, elegant deception that was being played on them. The Allies, meanwhile, were perfecting their new tactics. They developed the step-aside maneuver. A convoy screen would operate in pairs. When one escort, let's call it Ship A, detected a U-boat and drew a Gnat attack, it would immediately turn away, reduce speed, and stream its Fokker. This would draw the torpedo away. Meanwhile, its partner, Ship B, which had not deployed its own Fokker and thus had a clear ASDIC picture, would be vectored in. Ship B would sweep in from a different angle, unimpeded, to hunt down the U-boat, which had just revealed its position and wasted its most potent weapon on a decoy. The hunter had become the hunted once more, tricked by a simple rattling length of pipe. The Fokker deception had turned the tables decisively and permanently. The impact of the Fokker was immediate and war-altering. It did not sink a single U-boat, it carried no explosives, it was, by Shiji, a passive defensive tool. Yet it was one of the most decisive weapons in the final phases of the Battle of the Atlantic. The Gnat acoustic torpedo was Donitz's last, best hope to regain the initiative. It was a technologically advanced weapon that, for a few terrifying weeks in the autumn of 1943, threatened to completely unhinge the Allied anti-submarine strategy. And it was comprehensively and utterly defeated by two steel bars with hammers rattling inside them. Once the Fokker was widely deployed, the kill rate of Allied escorts plummeted back to virtually zero. The psychological advantage was ripped away from the U-boat commanders. Their wonder weapon had been rendered impotent. They could no longer terrorize the guardians of the convoys. This had a cascading effect on the entire Atlantic campaign. With the escorts safe, they could once again hunt with ruthless aggression. U-boat losses, which had already been catastrophic, continued to mount. The convoys, laden with the men and materiel destined for the invasion of Europe, sailed on. The successful protection of these supply lines, enabled in no small part by the Fokker, was a direct prerequisite for the D-Day landings in June 1944. Without the constant, uninterrupted flow of supplies, Operation Overlord would have been impossible. The legacy of the Fokker deception extends far beyond 1945. It established a fundamental principle of modern naval warfare: acoustic countermeasures. The cat-and-mouse game JAGPAM submarines and surface ships, less than Y_bin_258, greater than a new acoustic dimension. The simple mechanical Fokker was the direct ancestor of the sophisticated towed acoustic decoys used by navies across the world today. Modern systems, like the American SLQ-25 Nixie, are a world away in terms of technology. They are towed fish containing complex electronics. They can not only generate a wide range of broadband noise, but they can also listen to the specific sonar signals of an incoming torpedo, analyze them, and then broadcast a false doctored echo, fooling the torpedo into thinking its target is somewhere else entirely. Some can even replicate the exact acoustic signature of Luo parent ship. But the core concept, towing a loud attractive decoy on a long cable to seduce an incoming acoustic homing torpedo, is identical to the principle pioneered by the Fokker. It is a testament to the ingenuity born of desperation. In a war defined by radar, code-breaking and atomic physics, one of the most crucial battles was won with a clever, brutally simple piece of mechanical engineering. The Zugkönig was a masterpiece of German precision. But the Fokker was a masterpiece of Allied pragmatism. It proved that sometimes the most effective way to fight a sophisticated weapon is not with one that is more complex, but with one that is more cunning. It was a deception, written in the language of sound and steel, and it saved the ships that saved the war. And that concludes this story about the Fokker deception. If you want to learn more about World War II, subscribe, like, and share. Also, leave your anecdotes and ideas in the comment section.